In this short video about frequency diagrams and frequency polygons, we're going to learn about what they are, how to draw them, and how to interpret them, and also what do they mean. Frequency diagrams are pretty much bar charts, but they represent continuous data like time, height, weight, or temperature, so they've got no gaps between the bars. We count our data into groups, counting how many individuals belong in each group or class. Groups mustn't overlap, so it must always be clear which group an individual will be counted in. For example, here is some data about 33 students' heights. 10 of them are between 160 and 170 centimetres, 15 between 170 and 180, 6 between 180 and 190, and 2 between 190 and 200. Notice how each group's boundaries are defined. Here, 160 centimetres is less than or equal to the height is less than 170 centimetres. So if you were exactly 160 centimetres, you'd count as being in this group, but if you were exactly 170 centimetres, you'd count towards the next group. Another term you need to learn is modal group. It just means the group with the greatest frequency, that is, the group with the most people or items in it. Let's plot that on a frequency diagram then. Frequency on the y-axis and the heights in centimetres across the x-axis. The first bar includes the 10 students from 160 to 170 centimetres. Notice how the bar starts at 160 and ends at 170. The second bar includes the 15 students from 170 to 180 centimetres. Notice how it touches the previous bar because 170 centimetres is on the boundary between the two groups. There isn't a gap in the classes we've set up, so there isn't a gap between the bars. And here are the last two bars. Notice how this chart doesn't tell us the actual height of any individual student. It's just a grouped summary telling us how many students there are in total in each range of heights. This isn't raw data about individuals, it's summarised or grouped data. There were 33 students in total, so if you add up the heights of all the bars, they should sum up to 33. Now let's look at these frequency diagrams showing the height of some boys and girls. Adding up the frequencies, there are 30 boys represented in the left-hand frequency diagram and 30 girls in the right-hand one. In order to make reasonable comparisons between these sorts of charts, you need roughly the same number of individuals in each. So, which group of students are taller, girls or boys? Flicking back and forth to the left and right is quite tricky. It would be better if we could represent both sets of data together on one set of axes. This is where frequency polygons come in. Put crosses in the middle of the tops of each bar and join them up. Even though it's called a frequency polygon, the resulting line doesn't make a closed shape like a polygon, it's more like a line graph. The real benefit of frequency polygons comes when you plot multiple ones on the same axes, so you can directly compare two sets of data. You have to be careful when interpreting them though. Here, the polygon for girls goes higher than the boys one, so it's tempting to say girls are taller than boys, but that isn't what the graph is telling us. The y-axis is frequency and the x-axis is height. What we can see is that there is a higher frequency for girls than boys at shorter heights and a higher frequency for boys at taller heights. This means that there are more short girls than boys and more tall boys than girls. This implies that the girls are actually shorter than the boys on average. Again, if we had different numbers of boys and girls in our sample, this might lead us to false conclusions, but because we've got about the same number in each, then it's okay to compare the frequencies directly in each height range. Finally, there's something else to be careful about when interpreting frequency polygons. At first sight, this frequency polygon looks like it's representing the frequencies of heights from 165 to 195 centimetres. Don't forget that this is actually telling you about the midpoints of the top of a set of bars in a frequency diagram. The first point represents this bar, telling you there are 7 people with heights between 160 and 170 centimetres. The second point tells you there are 5 people with heights between 170 and 180 centimetres, and so on. So the final point here tells you that there are 13 people with heights between 190 and 200 centimetres. So overall, we could have heights between 160 and 200 centimetres. Remember, each bar should be the same width, and each point represents the middle of a bar. To summarise then, frequency diagrams are like bar charts for continuous data, so the bars touch each other. We join up the midpoints of the tops of the bars to make frequency polygons. We can then plot multiple frequency polygons on the same axes to help us compare different groups of individuals easily. We need to be careful how we interpret the frequency polygons. The y-axis is frequency, so the height of the polygon tells us how many people are in that group, not how tall or heavy, etc. they are. Because the points on the frequency polygon represent the midpoints of the tops of the bars, we need to be aware that there could be data values to the left or right of the endpoints of the frequency polygon. And we can use the fact that the bars are all the same width to work out where the end of the bars finish.